Good morning. All right. Welcome to Sysinternals Primer Gems. This is the third in the series of Sysinternals primers. The first one was, let me see, in Europe it was November 2010, and Tim Reckmeyer and I covered some of the main process or Sysinternals utilities: Process Monitor, Process Explorer, PS Exec. The following year, 2011, I actually myself did a Sysinternals primer in Atlanta. That was the year, of course, there was no TechEd here. But I covered a bunch more utilities: ProcDump, AutoRuns, which is a huge one for malware analysis, Disk to VHD, and a couple others. And both of those are available online. You can go to channel9.msdn.com and see the recordings of those. This one, since we covered the main utilities that everyone cares about, we wondered, I talked to Mark about it, Mark Rusinovich, and what are we going to do this time? Or what should I do this time? And we decided, one, do a bit deeper dive on some advanced features of some of the tools people might find useful, and then also talk about some of the stuff that nobody knows about. We got a list of the number of downloads of the different utilities, and we picked the ones that were downloaded the least to look for those hidden gems, things that you might be able to find useful in your work. So that's what we're going to talk about. The objective and what you'll be able to get out of this is you'll become a bigger Windows internals nerd than you thought possible. You'll be better able to bore your non-nerd friends to death, and probably your nerd friends as well. And if you have a copy of the Sysinternals book, you can get it signed by one of the co-authors. The book, the Sysinternals Administrator's Reference, came out last summer, and this is the authoritative guide for all the Sysinternals utilities. Every single one of them is documented in here in painful detail. It took me 2 years. Took us 2 years to write it, and it was because we wanted to make sure everything in there was accurate. There's full chapters on Process Explorer, Process Monitor, and AutoRuns, and all the other utilities are covered by groups. There's some background material in the beginning, some Windows core concepts that aren't terribly well documented elsewhere, and then in the back, Case of the Unexplained, the use of some of the utilities to solve real-world problems. And we're having a book signing right after this session, as a matter of fact, down in the expo hall, that way, I think, at 11:45. Now, of course, somebody in their infinite wisdom chose not to have a bookstore at TechEd Europe this year. So if you can run out and find a copy of a book, we'll sign it. But to help make up for that a little bit, MS Press and O'Reilly are giving away 15 copies of the book to the first 15 people in line. So everyone's going to rush out now to be first in line after 11:45. And everybody else who is in line will get a coupon for a free MS Press book, ebook. So even if you don't get the Dead Tree edition, you can get something. I've also got some coupons up here for copies of the book discounted through O'Reilly.com. So one of the questions I get asked a lot when people look at the book, they say, Aaron, what's up with the font sizes there? Why is Mark's name so much bigger than yours? I suppose it must mean that he did that much more of the work. How can I put this? Not exactly. No. Basically, there's this thing I found out about the book industry, and that is the name on the cover of the book sells copies. The right name on the cover, featured prominently. We've got David Solomon's name on the cover, too. And Mark is, at this point at least, still more famous than I am, probably forever, but basically, that's what it's there for, is his name prominently on the book sells books, right? So we're going to take this further for the next edition. Mark and I are absolutely thrilled to announce that for the next edition of the Sysinternals primer, the Sysinternals documentation, we are adding as a co-author none other than J.K. Rowling. We are thrilled about this. We see a lot of win-win here, right? We love having her name on our book. And, the thing is, she's been known pretty much just for the Harry Potter series and nothing else, really. And now she'll be able to reach an entirely new audience. And we estimate conservatively that through our partnership, she'll be able to grow her wealth by literally hundreds of dollars. So we think she'll be really excited, probably not as excited as her lawyers will be when they find out about this. So let's dive in. Process Monitor. I assume most of you are familiar with Process Monitor and use it on a regular basis. Can you show of hands how many of you use Process Monitor on a regular basis and spend more time with it than with your families? As do I. So I'm not going to go over the basics of Process Monitor. I'm going to assume you already know those. I'm going to talk about some advanced filtering stuff. So, Process Monitor captures a lot of information, and one of the first things you have to do is filter down the information to just the stuff you're interested in. And so understanding filtering is critical. One thing that's commonly misunderstood are when you apply a bunch of different rules, how are they prioritized and combined? So within a column, within an attribute, they're ORed together, and between columns, they're combined with AND. Let me give you an example. So an attribute such as process ID. You set a bunch of rules for process ID. You set rules for path. Okay? Within the attribute process ID, those rules are ORed together, and between them, they're ANDed. So in this case, what you would get if you applied these 4 include rules is you would get all the events where the process ID is either 1512 or 2408, and where the path contains HKLM or zones. Okay? One of the places where people get tripped up is when they apply filtering rules to attributes that can overlap. For example, process name and process ID. This one trips people up fairly often. Okay? So let's say you're looking at all the processes and you say, I want all the command.exe processes, and I want these 2 processes as well, and they're picked by process ID. What happens here? The way the rule is applied is it's going to list all the events where the process name is cmd.exe and where the process ID is 1512 or 2408. Okay? And this often results in nothing. So let me see if I have I can demo this really quickly. So one thing you need to know about the filtering rules, if I start capturing some stuff and refresh here on this, and I want, let me see, let me run that process trace a little bit longer. A couple different ways you can apply filters. One is you can go into the filter dialog and just enter things. So process name is cmd.exe, right? That's one way to do it. Another way is to apply filtering rules using, for example, the process tree. You can select a process in here and select that and say include process. What happened? There's nothing left because process name is cmd.exe and process ID is 2576. There's no intersection between the 2. Another way that you can apply a filter that trips people up sometimes is to use the crosshairs icon, drag that over another window. That sets a filter based on process ID as well. So be aware when you're using process name filters that a lot of the ways that you would normally use to apply a filter are going to use process ID filtering. Any questions about that? So what if you want to limit within a column? What if you want something where the path contains HKey local machine and zones, but nothing else? Ordinarily, if you apply this rule, you're going to get anything that contains HKey local machine or zones. Let me demo that again. So let's clear that out, fire this thing up, do a refresh here. This utility looks at registry values, a whole bunch of different Internet Explorer related registry values. So I get a ton of registry activity from it. Stop the trace, set a filter on this process. Now if I set a rule here where path contains HKLM backslash and path contains backslash zones, add that. Okay, so I have a process ID filter, so I'm just looking at the one process, and then two path rules, and I set that. Now let's see all the registry keys. I'm going to do tools registry summary, and I can get a listing. I can sort that. These are all the registry entries that were captured by the trace. And you can see here there's a bunch of HKey current user because it has zones in it. If I scroll down, I've got a bunch here where here's HKey local machine, but it doesn't have zones. So I'm capturing a lot more than I want. In this case, 9,490. So how do you filter it so that you get just the ones that contain HKey local machine and zones? And the way that I recommend is, rather than say these are the ones I want, use the exclude rules to say these are the ones I don't want. So instead of saying I want all the HKey local machine, what you say is I don't want it unless it has HKey local machine and zones. So demo that. There's a neat tip about editing a rule. Once you've put a rule in here, you can edit it by selecting it, double-clicking it. It removes it from the list and puts it back up here. So what I'm going to do is, instead of path contains HKey local machine, I'm going to say path excludes HKey local machine. Does not contain HKey local machine, and then exclude it. Add that rule back in, and come here and grab this one and do the same. If the path does not include zones, then I don't want it in the trace. Now here you can see that the rules seem to have disappeared. That's because they're exclude rules. They end up at the bottom. So they are down here now. Okay, let's see how that works. Apply that rule. Now we're down to 3,089. And if I do tools, registry summary, sort, and we can see here everything in here is HKey local machine and zones, nothing else. Zones, HKey local machine. No HKey current user, and everything contains the word zones. So does that look helpful to you? A little bit? Did I put you to sleep already? Is this too nerdy yet? All right. Well, if that was too nerdy, you're going to hate this. I'm going to talk about the environments in which Windows processes run. And these are terminal services sessions, Windows stations, desktops. And we're going to start out by talking about windowing, because it's important to understand this. I'm going to talk about these and then how they impact some Sysinternals utilities, how they can surprise you in some ways, and also how the Sysinternals utilities can expose some of what's going on under the covers. So going back to Windows 1.0, in the Windows graphical environment, you had the concept of windows, which are the outer frame of an application, the buttons, the text boxes, static text, things like that. And a window manager that processes messages that go between the program and other things on the system. So for example, this program here, Calculator, has a bunch of windows on it, including buttons and text boxes, like I said. Another program on the desktop can ask the window manager to give me a list of all the windows that I can see, and let me send messages to them. Well, what does a message do? A message might tell a window, you were clicked in this location, or this key was pressed, or you are being moved to this other location, or you should redraw yourself now, or you should set your text to this value. Program 1 can ask the window manager, is there a window around here with a title calculator? And the window manager will say, yes, there is. This is the identifier of it, the handle to the window. And now program 1 can use that value to send a message simulating a button click and cause program 2 to respond to that button click. So the thing here is that a program in the graphical environment cannot reliably tell, did this window message indicating a mouse click or a key press actually come from an end user physically touching a keyboard, or was it just some other program simulating the keystrokes, perhaps with send keys? I'm sure some of you are familiar with that. Let's see how that can impact some apps. So here is a sample program, and this thing has windows on it. I can actually see some of the windows. You remember the crosshairs icon? You may have noticed, this is with Process Explorer, you can find the process that owns a window by clicking the crosshairs and dragging it over a window. And you can see here there's multiple different window objects in here, this text box, this static text, this button. I release this and it tells me this is the process that owns it. So I have all these windows. Whoops, wrong click. And I can type in here. Now, at the end of the day, when I type, it's ultimately a window message that's telling the program to update its text. And I click this. But it could just as easily be another program. This program knows to look for this other application and look for the windows and send it messages. So I can send a message this way. I can simulate a button click. This app doesn't know any different. Okay, now, beginning with Windows Vista, it was important not to allow applications running at lower privilege levels to be able to control apps running at higher privilege levels. And beginning in Windows Vista, we started having that be a very common occurrence, where you'd have programs running at different privilege levels on the desktop. Right? So you've got protected mode Internet Explorer running at low integrity. You don't want it being able to control something running at a higher level. You can also have something running with full admin rights. You don't want something running with standard user rights to be able to control it by sending it window messages. And so Windows introduced something called user interface privilege isolation. And what that does is it blocks window messages going from a process at a lower integrity level from going to a process to a window owned by a process at a higher integrity level. It allows through anything that's just a read operation, like what is the text in your title bar, but it won't allow messages that might control the higher level application. You can see in Process Explorer the integrity level. If you add the integrity level column, you can see here of these two apps, they're both running at medium. And so there's no restriction on sending and receiving window messages between them. So let's take advantage of a Sysinternals utility here. PSExec, we're going to run a program. This one here, I'm going to run it at low integrity instead. And I can do that with PSExec, PSExec-L. Okay. So now this thing is running at low integrity, as we can see here. So now I can read the content out of this text, but I cannot change it. Okay, so the window messages are blocked if they might modify or control the higher integrity program. Access denied, trying to click that button. Now, how does this impact Sysinternals utilities? There is one case in particular where this comes up, probably a few actually, and that is with auto runs. How many of you have run auto runs before? How many of you have used the feature to jump to a location? So you have these auto start entry points. You right click and you can say jump to entry, right? To find where is that auto start entry point actually configured in the registry. You click jump to entry and nothing happens in this case, because here we've got regedit. Because I'm a member of the administrators group, where's regedit? Regedit here is running at high integrity, and auto runs in this case is running at medium integrity. If I have auto runs, I have another copy here running with full admin rights. This one, I right click, jump to entry, and it's able to do it. The reason this works is because auto runs and the jump to entry feature is actually sending window messages, simulated key presses, to regedit to navigate to that location. You know, there's no command line for regedit to say go to this location. So autorun simulates that by sending window messages simulating the key presses. And user interface privilege isolation can get in the way if they're running at different levels. Another utility that's similar to that is regjump. This is a command line utility that allows you to programmatically, in a script, for example, open up regedit and go to a particular registry key. Uses the same functionality. So again, here I'm going to try to go to HQ Local Machine Software Microsoft Windows, and nothing's going to happen. Again, because of user interface privilege isolation and the fact that regedit is running at high integrity. If I do it from a command shell or a PowerShell that's running with full admin rights, it's able to use it. So, as long as I'm looking for excuses to show Sysinternals utilities, we can answer the question, why is regedit running with admin rights? I'm a member of the administrators group, and if I launch regedit, it always prompts for elevation. But if I'm running as a standard user, it doesn't. We can answer that question by using a utility called SIGCheck. SIGCheck is primarily used to show version information in a file as well as digital signature information. Is this file signed by whom? Is the signature valid? It can also be used to show something called the manifest that's embedded in an executable. So if I do sigcheck-m, see Windows Explorer.exe, here's the manifest. It's an XML document that's embedded within Explorer.exe. And one of the things that's in executables that are built for Vista and higher is this security section that specifies whether a program needs admin rights or not. So Explorer is marked as invoker, which means it doesn't need admin rights. If it's launched, just go ahead and run. Contrast that to sigcheck-m, see Windows 32 disk part, which always requires admin rights. And so within its manifest, it's marked require administrator. So what's up with regedit? sigcheck-m c:\windows regedit.exe. It's marked with this thing called highest available. And what that means is if the user can elevate, if they have a split token and they can elevate within the user account, for example, you remember the administrators group, half the stuff you run runs as standard user and half as admin, even though it's the same account. If you can elevate, demand elevation. And so regedit, if you're a member of the administrators group, always demands elevation or it won't run. It's because of highest available. So that's window messaging. And like I said, this architecture goes back to Windows 1.0. windowing takes place within a construct called a desktop, and this was introduced in Windows NT. A desktop is a logical display surface on which UI is drawn, but there can be multiple desktops which are separate from each other. You'll have a default desktop, which is where your normal apps run. If you have a password-protected screensaver enabled, when Windows starts the screensaver, it creates a screensaver desktop, switches to it, and runs the screensaver on that desktop. And then finally, there's the WinLog on desktop, also known as the secure desktop. When you press Control-Alt-Delete, Windows switches over to the WinLog on desktop to display the, do you want to change your password? Do you want to log in? Do you want to unlock the machine? The WinLog on desktop is called the secure desktop because only processes running as local system can do anything on that desktop. No standard user software can even look into what's on that desktop. Another thing about desktops also is that window messaging happens only within a single desktop. You cannot enumerate the windows that live on another desktop from the one your process is running on. You have to be on that desktop in order to enumerate those windows or to send messages to them. So this provides some kind of isolation between desktops. And in fact, you can create your own desktops programmatically. There's APIs to create a desktop. You can switch to the desktop. You can perform operations on there. One example of that is the Microsoft Office Isolated Conversion Environment, MOICE, which is used in some versions of Office. If you want to, let me see, I think this was introduced for Office 2000. I can't remember what it was used for. Rats. Basically, we're converting documents that may be risky, right? We create a separate desktop, lock it down, and run some code on there. So if malware happens to run in there, it's much more sandboxed and much more isolated. It cannot see the windows of your main desktop. And of course, there is another utility that creates desktops, and that's a Sysinternals utility called desktops. We have to talk about this. How many of you have seen this before? Okay. Bit of history. Microsoft acquired Sysinternals and WinTernals in 2006. Prior to that, if you wanted to run a Sysinternals utility, you ran the utility and it worked. All the time because they never had any bugs at all, right? No one's ever run into a Sysinternals bug, right? Okay, good. Now, we acquired Sysinternals in 2006. Now, people seem to think that Microsoft is made up primarily of programmers and testers, and maybe some marketing people. In fact, Microsoft's employee base, 5/6 of them are actually lawyers. And so, when we acquired Sysinternals, we insisted you cannot run a Sysinternals utility unless you approve and accept the end-user license agreement. And so every single Sysinternals utility, including the command line ones, were retrofitted to pop up a dialog. And you cannot accept it until you've read it. So I'm not going to read this out loud. Everyone raise your hand when you've read through this, and then I'll page down. And we'll get to the bottom of it before the end of the session. Okay, good. Okay. We'll skip the rest. You're all bound by the end-user license agreement. So here's desktops. And what this does is it allows you to create additional desktop objects, and then it switches to that desktop, launches Explorer on it. Now you've got a completely separate environment. And it gives you the option to set hotkeys to switch between them. And by default, it's Alt 1, 2, 3, and 4. So here's desktops, and I've got my main desktop that I'm on. Here's desktop 2. I can create that. I've got a completely separate environment where I can do stuff that I want to do, like play solitaire. Or I can try to play solitaire. Okay, this is very good. Now, I can do what I want to do until the boss comes by, and then I hit the hotkey very quickly and pretend like I've been doing work the whole time. So this is desktops. Let me show you a utility that I've written, and I will post it on my blog sometime very soon, called TS Sessions, which we'll look at a lot today. And you can see here, Windows Station is the current session. There is the default desktop, and now there's Sysinternals Desktop 1. And if I do this to create a few more desktops, and then switch back, or I can just do it from here. This shows that I am now running on the desktop, Sysinternals Desktop 3. This is the current desktop. It's the current user input desktop. Switch back over here. I'm now back on the default desktop. Now, one of the things about these desktops, like I said, you cannot view into other desktops and see the windows on other desktops. So here's Process Explorer. I have right here, this app is running on the same desktop. If I right-click here, Process Explorer can enumerate all the windows on the current desktop and see that there is a top-level window associated with this process, and I can switch to it. However, Solitaire, which is running on a different desktop, I right-click that. I don't have the option to go to that window. Another case where windowing and desktops come up has to do with Process Monitor. So one of the things you may want to do, let me do this from an admin command prompt so I don't have to go through the... You may want to programmatically control Process Monitor. Whoops, where is it running? What desktop am I on? Alt-1. There it is. Just close that. You may want to programmatically, you may want to write a script to capture a trace, save it to a backing file, and then shut it down. And you may want to do this in a script. And there's command line options you can use to say, use this backing file and save stuff to that backing file. Now, when you're running Process Monitor that way, you can't just kill Process Monitor because Process Monitor has to shut down cleanly to close the file. Otherwise, the file is corrupted and you can't use it. So there is a command line option. Actually, let me do this one more time just to make sure it's come on. There we go. Get that up, and we'll watch this with Process Explorer. Here's Procmon right here. I can terminate it with this command line, procmon/terminate. That looks for the other instance of Process Monitor and shuts it down cleanly. Bring this to the foreground, run this. You can see this starts, and then they both exit. There's a clean shutdown of Process Monitor. The thing is, /terminate uses window messaging to send to locate the other instance of Process Monitor to tell it to shut down. So it has to be running in the same desktop. If I run procmon here, and then go over to another desktop, run procmon/terminate, it's not going to work because it's on a different desktop. This comes up when you're running Process Monitor primarily in a non-interactive context. And I'll talk about those when I talk about Windows Stations and Terminal Services sessions. I come back over here, procmon's still running. So it's important to have it on the same desktop. Another case where this comes up is with procdump. Procdump is a utility that lets you capture a user mode dump of a process based on various criteria, like it's taking up too much memory, or it has terminated, or the CPU cycles have gone up too high, past a certain threshold. One of the options you have is with /h, or -h, is to look for a hung window. If the app has a window and goes not responding, you can use proc dump to capture a process dump of that. Again, using windowing and windowing messages to determine whether it's hung, it has to be running on the same desktop where your target process is running. So one last thing I want to show you here on this topic, and that has to do with the WinLog on desktop. You know, if I press Control-Alt-Delete, I go to the WinLog on desktop. Here's a cool trick, psexec. I want to run something as local system. Only stuff running as local system can appear on the WinLog on desktop. -X says run the target program on the WinLog on desktop. -D says don't wait for it to return, and we'll do CMD. Okay, process ID 3684 is right here, 3684. It's running as local system. And if we look at window handles, we can see it is on, or appears to be on, the WinLog on desktop. At least it has a handle to it, to that desktop. So let's go over and see if we can find it. Where might it be? Let's try Alt-Tab. Haha. There we go. TS sessions. And there it is, running on the WinLog on desktop. Amaze your friends. So that's desktops. Desktops live within a construct known as window stations. Now, a window station obviously has one or more desktops, and it also has a clipboard. So the clipboard is global to all the desktops within that window station. So anything that you put on the clipboard in the default desktop is visible to applications running on the screensaver desktop or the other desktops or the WinLog on desktop. WinStay0 is a special one. It is the one that it's the only window station that can actually display UI on a screen or receive user input. The other window stations are for services, and there's a separate window station for every user account or service account that is logged onto the system. So the desktop with 3E7 belongs to local system. That's where the services, the non-interactive services running as local system execute. 3E4 and 3E5 belong to network service and local service. So services running in these different contexts will run on these different window stations and have some degree of isolation between them. If you have a service account, a custom account that you've configured a service to run as, it will get its own window station with a logon ID. We'll talk about that in a little bit, incorporated into the name. One thing about this also is if you have a service where that's configured to run as local system, and you check the box that says allow the service to interact with the user desktop, which we do not recommend, what happens then is the service, instead of running in the 3E7 window station, runs on the WinStay0 window station. And if it displays any UI, that appears on the end user desktop, which, because of what you saw earlier, creates a huge risk, because now you have windows belonging to a process running as local system that can be controlled by other windows or other programs running in the same space. By sending window messages, you can create what's called a shatter attack and control something running as local system. Easy elevation of privilege, which is why users never log on anymore to what is called session 0, which we'll talk about right now. Now, the name WinStay0, I've never been part of the Windows team. I'm actually in Microsoft Consulting Services. I've never been in a product group, so I don't know with certainty the history here. But I think the inventors of Windows NT always intended that at some point in history, Windows NT would support multiple simultaneous user sessions, interactive user sessions. The name WinStay0 suggests to me that they figured at some point we'll add WinStay1, WinStay2, etc. But that's not actually how they ended up implementing it. When terminal services finally came around in NT4 Terminal Server Edition, Windows 2000 terminal services, Windows XP fast user switching, and all that kind of thing, they built on top of what they already had and created terminal services sessions. So now, as you create additional sessions, interactive sessions, they get increasing numbers, session 0, 1, 2, etc. So when you have multiple users logging on, say, through remote desktop, each of them is going to get a separate session. All these additional sessions only contain WinStay0, so they're always interactive sessions. In Windows XP and earlier, when you logged on, there was a very good chance that you were going to log on to session 0 and be in the same space with where the services are running and where you could have interactive services switching over. And because we wanted to make sure people could run as standard user and to reduce the risk as much as possible of elevation of privilege attacks, we created what's called session 0 isolation. Users never log on to session 0 anymore. They always get session 1, 2, 3, etc. You can see the session number associated with a program by adding the session column in Process Explorer. As you can see here, a lot of these processes are running in 0 and a bunch of them in 1. If I go here and do switch user, not log this user Abby off, but log in as Toby, then what's going to happen is I'm going to get session 2, and you're going to see programs running there. So let's have, now let's see, this is a useful thing. I'm sure you know this one already. psexec, run something as local system. I says run it interactive. D says don't wait for it to return before returning control back here. psexec sid cmd launches a command prompt running as local system. Okay, it's running here on the same desktop. Run ts sessions. No SD says don't show the security descriptors, otherwise I show a bunch of security descriptor output. You can see here, this is running in the same space as the apps are already running. Session 1, WinStay0, default desktop. Let's do something else here. Let's do psexec -s cmd. So not interactively, but run it as local system. Where does that go? Let's see. We've got here now, go psexec service. So it launched this service to handle this, and now there's a cmd.exe running in session 0. If I look at the window handles, I can see it's on the default desktop of the local system window station. So this is running in a non-interactive context. We'll run that utility ts sessions. You can see here that, in fact, it is running in session 0, the non-interactive session, default desktop. So what psexec is doing here is it's kind of like a telnet. It has created this remote process, and it's redirecting console I/O back and forth. So standard input that I type in goes to the standard, is sent to the standard input of that remote CMD. Any standard output or standard error that comes back gets shown on my desktop. So because it is only console I/O, there's no console coloring, tab completion, no concept of where am I on the command line. So things like CLS won't work, right? And console coloring and tab completion. Another thing that's important to know about this, I keep wanting to do CLS, is if I do, so all the keys I type, they get sent over, and anything that it produces comes back, with one particular exception, that is Control-C. If I type Control-C, psexec uses that as a command to kill the remote process. So if I do dir as, or sa, enumerate all the files on the file system, now your inclination at this point is to press Control-C to stop that output. You can do that, but you're killing the remote command shell, not just the cmd.exe. And you can see here the command shell is no longer there, and for some reason psexec service didn't realize it, so I have to kill it too. Otherwise, it just hangs there forever. So be aware of that. So some of the things you can run into, you may want to run stuff as local system in this non-interactive context. I talked about using procmon non-interactively, running it from a script. Say you want to see what's going on during logoff, and you want to capture all the events that are going on during a logoff. If you run process monitor on your desktop and then log off, process monitor is going to exit along with all your other processes. So running procmon in this context, in the remote, non-interactive Windows station, is a great way to run process monitor and have it survive logoff. But you need to do it carefully. There's some command lines you have to use because you want to make sure there's no dialogues that get popped up. Let's talk about that here. Let's do psexec. I'm going to run this utility called access check. Access check is a Sysinternals utility that can show you security descriptors and permissions on all different kinds of objects, including registry keys, processes. I'm just going to use it here to look at the directory permissions on C:\\. Enter, and the output should come any second. And it's not. So let's see why it's not working. We have psexec service. We see access check is launched, and it's not doing anything. It's consuming not one single CPU cycle. Why is that? We can go to the threads tab. We see here's a thread. It is just sitting there idle. We look at the call stack, and we see here access check is called into user32 DLL and has invoked a function called dialog box indirect param. What do you suppose that is? Thank you, lawyers. So access check has popped up a dialog box in a non-interactive context where it is impossible to click on the accept button. So what do you do here? Nothing. All you can do at this point is kill the process. And we'll try again. Now, this is where it's important to note that, yeah, we put the dialog box, we forced the dialog boxes into all these programs, and it obviously broke a lot of scenarios, so we finally got the lawyers to say, okay, you can use an alternate mechanism to indicate that you accept our end-user license agreement, and you can do that by adding accept EULA to the command line. Okay? Now, you have to do that for psexec, right? But I've already done that, so psexec isn't prompting me anymore. So let me do that for access check right here. If I do this and I accept this license agreement, now I can see the output. Is that going to help me here when I run it in the remote context? No. The lawyers insist every single user who uses the tool has to accept it on every single machine. So the local system account has to approve this end-user license agreement. Insert lawyer joke here. So accept EULA. Now I'm going to run access check in this remote context, and it works. And now the system account has approved the end-user license agreement. Let's do this with another tool. psexec s pipelist. Pipelist is a Sysinternals utility that enumerates all the named pipes on the system. And it's hung. I wonder why. Go to the call stack, and yes, indeed, pipelist has called into dialog box. So kill pipelist, and let's do the same thing here that we did. And we'll do pipelist accept EULA, right? Spelled correctly. And nothing. What's going on? It's still calling dialog box. Why is that? So we retrofitted all the apps with the dialog box, the end-user license agreement, and the lawyers then came back and said, you can use accept EULA, and Mark and Bryce Cogswell, the other Sysinternals guy, Said, okay, as we update the tools, we'll add support for /accept EULA. Pipe list has not yet been updated. So it does not know about accept EULA. So what do you do if you want to use pipe list in a remote context like that? Basically, what you have to do is put in the registry key that accept EULA ultimately leaves behind. And you have to do it in the same context because it has to be local system. So psexec/s, reg.exe, command line utility for updating, for manipulating the registry. Add hkey current user, because it has to be hkey current user for the system account. Software sysinternals pipe list. Create a new value called EULA accepted. It is a reg dword, and the value is 1. And now we can run pipe list. Okay. Has this been nerdy enough for you? Let's go just a little bit deeper. So that's terminal services, sessions, Windows stations, desktops, window messaging, etc., and some of the issues you can come up with. And I think we've done this demo to death by now. Let's talk about LSA logon sessions. So you've seen terminal services sessions. I think you understand them pretty well. You log on, you Control-Alt-Delete, you do remote desktop, you get a full interactive session. There's other ways to authenticate to a Windows system, right? For example, you can have a service configured to run as under a service account. Username, password. It has to log on. What happens with that? You can do a net use and authenticate to a remote system. When you authenticate, Windows has to figure out who you are and what rights you have. It creates what's called an LS. It's the LSA that does it. It's the local security authority creates something called a logon session, and it keeps track of things relating to your authentication. And naturally, there is a Sysinternals utility that will show you some of that information. Every logon session gets a session ID, a logon session ID. Here's the one for local system with 3E7. Now you see where the Windows station names came from. So this is one for local system. You can tell because of the well-known SID S1518, which is local system. It translates the name, interestingly, into workgroup or domain machine name $. Likewise here, 3E4 is the network service account. It also gets that same name. 3E5 is local service, but it translates to NT Authority local service. So this is the SID to name translation. Under the covers, it may translate to NT Authority system, or it may be machine name $. It uses machine name $, in this case for some reason, because in an Active Directory environment, both the system account and the network service account, when they authenticate on the network, use the machine credentials and authenticate as the machine account, whereas local service always authenticates as anonymous. There is also here an anonymous logon session representing an anonymous user. So each of these logon sessions has an access token associated with it. When you log on, it creates an access token that says this is who you are, these are the groups you're a member of, these are the privileges you have, and it uses those when it performs access checks. Processes or threads that run on the system have some token that derives from one of these logon sessions. And if you log on and use anonymous credentials, like guest or something like that, it will take a token associated with the anonymous logon session and use that for access checking. Now here we've got, let me see, I've got this service account. I've got a service configured here using this custom service account, you can see its logon type is service. And I've got here my interactive user, Abby. And it is an interactive logon type. And if I do, let me do a net use here real quick. I do net use Win7x64VM. I believe in security. This is a complex password. It has upper and lower case symbols and digits. Let's do logon sessions again. We can see here now there's this additional logon session associated with Toby that's a network logon type. These logon types and the fact that these sessions exist has some security implications. So did anybody go to the Roger Grimes, Mark Simos talk a couple days ago where they talked about pass the hash? 2, 3, okay. So when you have an active logon session on the system, all these logon sessions also have an NT hash associated with them. On the network, the hash is just as good as having username password. And so if a domain admin has logged onto the system and their logon session is still in memory somehow, then its hash can be grabbed and an attacker with admin rights who can go through this stuff can then authenticate as the domain admin. Network logon types are not as risky because they don't include the user's credentials. This is interesting, though. There's 2 logon sessions for Abby. I logged on one time here, and I've got 2 logon sessions. Anybody have any idea why? UAC, user account control. Let me show you something else you can do here with logon sessions. If I add -P to the command line, it lists all the processes for which the process token is associated with the logon session. So here you see, this is the system account. These are the processes that have the system, that are running as system. These are processes running as network service, local service, and here, processes running as Abby, in this case, Process Explorer, regedit, which we know is running with admin rights. These are the ones running with admin rights. These are the ones running with standard user rights. So what UAC does is when you log on, if you're a member of a powerful group or you have any admin equivalent privileges, Windows actually creates 2 separate logon sessions for you. One representing you with full admin, with whatever your full rights are, typically full admin rights and all the privileges, and it creates an access token that has all that in it. And then it creates another one where the access token is filtered down. Powerful groups are disabled, and powerful privileges, like the debug privilege, are removed from the token. Then it launches Explorer, or whatever your shell is, using the token derived from the filtered side. And then that's used for all your work. Until you say, I need to run this thing elevated, then it goes and grabs the token from the high side and applies that token, and that's the one you run with. So an implication of that is, have you ever noticed when you're a member of the admins group, you log onto a system, you've got map drives on the network, and then you bring up something, a command shell, for example, with admin rights, fully elevated, and you try to go to your map drive and it doesn't work. Anybody ever notice that? Where'd the definition go? The reason this happens is because things like drive mappings are associated with logon sessions. So the drive mapping is associated with with your non-admin logon session, but not your admin logon session. Let's peer around with some of that and we can see some things. Let's grab this session ID, this LSA session ID. Let's search for things that are associated with that. Okay, so here are a bunch of tokens that derive from that session. Here are some event objects that appear to be associated with that logon session. And here's something, a directory that's associated with that. We can a directory is an object in the Windows Object Manager namespace. And Sysinternals provides a utility to peer into that. I'm going to run it with system rights to get the best visibility into it. It's called WinObj. And let's navigate to that spot, WAC session 0 DOS devices and the session ID. Session 0 DOS device session ID. So this is stuff associated with that session. Let's go and create a subst mapping. Actually, let's do a netuse. Netuse W Win7x64VM $$ Windows. Refresh. You can see it's associated with this logon session. Now I go to a standard user command prompt, and I'll create a subst mapping to this temp folder. And you can see here that it's associated with this logon session. They're separate, though. Even though they're both running as Abby, I can't go to W from here, and I can't go to T from here. Now, don't try this at home, what I'm about to do. But did you notice here that these things, there's a 3E4 and a 3E5, which are for network service and local service. There doesn't seem to be a 3E7 for system. Let's see what happens. psexec syd cmd. I'm going to, where should I do it? New directory, and I'm going to subst x to c:\new directory. Just to prove that we're there, I'm going to go into x and echo hello to hello.txt. Now let's see if this works. Here, running as Abby, can I go to x? Remember, I couldn't go to the one associated with the other one, with the non-admin one. X works here, and X works here. It's because drive mappings that are associated with the system account are global to the entire computer. We go here into the Object Manager namespace, global. Global names include A:, which maps to WAC device, WAC floppy 0 on this machine, C:, which maps on this machine to WAC device, WAC hard disk volume 2, D to the CD-ROM, and EWX to global C:\new directory. So cool stuff you can find if you peer around in here enough. Like I said, don't try this at home. Any questions about any of this in logon sessions? The last thing I'm going to talk about has to do with NTFS and the file system. There's a utility called DU. It comes from there's a Unix command called DU, which shows you the amount of disk space taken up by a folder structure, directory structure. Now, you would think that listing, how much space does this is taken up by the stuff inside this directory structure would be pretty easy. You just enumerate through all of it, and you count it up. It's actually harder than that. If you want to do it accurately, and you want to take into account things like hard links. Okay, a hard link is you've got the content in one spot on the physical drive and then multiple directory entries pointing to it. Okay, the space is only taken up one time, and then you've got multiple directory entries. So if you're counting it for each one, then you're getting an inaccurate count. You have to take into account alternate data streams, which may be associated with files. You have to take into account junctions, where both things may appear to be a directory, but they're actually going to the same place. And then there's things like, how much actual physical space is taken up if you have a 20-byte file. If it's taking up a 4K cluster, then you want to take that into account. And DU does all of that. Just minimize all of this. I'm going to switch to my old person glasses. I'm going to get rid of this system prompt so I don't get myself in any more trouble. Okay. The basics first. Let's go into the program files folder, and we'll do du dot. Yes, lawyers, we love you. Okay, these are the number of files, these are the number of directories. There's the size and the size on disk. Now, the size on disk may be larger or smaller. If the drive is compressed, or the folder structure is compressed, size on disk will typically be smaller. In this case, this indicates that there's a bunch of small files which take up a bunch of clusters. So there's a lot of empty space there, taking up more space on the disk. If you want to see more detail, you can do du/-v, which says show all the directories and all the space taken up under all of them, but under program files it's going to be a lot. So I'm just going to go down one level, show just one level. Okay, and let's do that again with -q to get rid of the banner. So we've got the output filtered a little bit. So you can see here, common files takes up this much space. I've got the debugging tools which take up 40K and so forth. From here, it's easy to do things like sort the output. Okay, you can also go down another level, going -L2, and you can see where things are actually taking up space. If you like this, if you want to capture something so that you can see, if you want to capture it instead of in a text output, you want to capture it as a CSV. This is a fairly new option. Use -C, and it outputs as a CSV. Now you can save that as a CSV and open it in Excel and manipulate it that way. So hopefully that's useful. Let's go to the temp folder and do some more complex stuff. I'm going to create a directory called 1, and I'm going to copy C Windows Explorer into it. Okay, so I do a directory listing, and you see the dir. Now, dir doesn't do anything that du does, or it does only the minimum. It actually does the dumb count. So it sees here that there's 2.8 meg. I'm going to create a junction now using makelink. So now you see there's a folder called 1 and a junction, another pathway to it with basically the same content. Explore.exe is in both. How much space is taken up? According to dir, 5.7 meg. Now we know that's not the case. So du only counts at one time. Du does not traverse junctions. It just assumes I'm going to find that some other way, so I'm not going to enumerate that here. Let's create a separate directory. And what I'm going to do now is create a hard link. Makelink is built into Windows. It's actually part of cmd.exe, so you can't do it from PowerShell. It's unfortunate, but it's a built-in command of cmd.exe. Now, what I'm doing here is creating a hard link, identifying the name exp.exe in the 2 directory to explore.exe in the 1 directory. If I do dir, again, it's now counting 8.6 meg. I've got one file here that's 2.8 meg, and it's seeing 8.6 now. du/v-v, it sees it one time. So it traverses the second directory, but it notices I've seen this file before. So when it counts exp.exe, it sees this is already something I've already counted. Let's take a look at how it knows that. Here's find links. This is another, almost, I think pretty much brand new. I think this came out last summer, right around the time of the book. Find links is a Sysinternals utility that will show for any given file, are there any other files associated with it through hard links. So one explorer.exe is linked to c:temp2.exe, and it has an index number. So du tracks the index numbers and sees, I've seen this index number before, so I'm not going to count the file again. Let me show you something else with find links real quick. Find links c:windows notepad. How many places have you seen notepad on your system? There's c:windows notepad, which is linked to system32 notepad. I think in previous versions of Windows, there were actually separate copies. Now it's one copy on the hard drive with multiple directory entries pointing to it. So there's system32, and there's a couple in the WinSXS folder, the side-by-side folder. If you go through the system32 folder and the Windows folder, you'll see lots of stuff linked, hard linked to stuff in the WinSXS. So you don't want to go and delete that stuff. Okay. Let's see what happens. I have this thing. If I delete this first entry, does that mean it's gone? As long as there's multiple hard links pointing to the file, until all the links are gone, the content is still on the hard drive. So dir/s now shows just one because ctemp1 doesn't show anything, but it's still in there. du/v. Now look, earlier we saw it counted ctemp1 had 2.8 meg. Now it's ctemp2 because now there's nothing in one. It sees the file in the second directory, but that's the first time du has seen it, and so that's when it gets counted. So that's hard links. Let's talk now about alternate data streams. And what I'm going to do, has anybody ever noticed when you download a file from the internet, you have to unblock the file? Windows uses an alternate data stream to mark the file to say this came from the internet. You can remove that alternate data stream, and that's equivalent to unblocking. So I'm going to take C Windows regedit. I'm going to type it out, and I'm going to append it to this file. This is the syntax for indicating an alternate data stream. File name : name of the stream. Okay, so if I do dir/s, dir doesn't see that there's an alternate data stream associated with this file. Although, in the latest versions of Windows, you can enumerate alternate data streams using -r. So here it sees that exp.exe has this alternate data stream associated with it, but it still doesn't add it up. Whereas du will count that and sees that this file is actually bigger than it used to be. You can use the streams utility from Sysinternals also to enumerate alternate data streams that are found in the file system. Okay. So, just about ending right on time. Some resources you can go to. What I do to get to Sysinternals, I go to sysinternals.com. It redirects me to its location on technet.microsoft.com. I recommend you subscribe to Mark Rusinovich's blog at this address. I've got a couple blogs also where I talk about Sysinternal stuff and non-admin stuff and security lockdowns and a bunch of other stuff I'm passionate about. So check that out. And the TS Sessions utility I was showing here, I will be posting that to the Aaron Margosis blog on MSDN probably within the next few days. We got the track resources. We've got this and the evals. Now, you have it in your power to make me the highest rated speaker at TechEd this year. And I hope you'll take advantage of that unique opportunity. The book signing is in about 15 minutes down at the down in the expo hall. I've also got these coupons here for copies of the Sysinternals book, 40% off the print book and 50% off the ebook through O'Reilly.com. So you can come up and pick up one of these if you like. Thank you very much for coming. I hope you got something out of this. I hope you had some fun. I hope you're nerded out.